All right, part two with TikTok. I don't know what happened. I couldn't go back and continue that video. So anyways, we're doing the generator system, guys. Here's the pedestal. Here's my outdoor NEMA 3R box. I have a 1-inch sleeve going inside to my automatic transfer switch, and I'm going to be pulling a 50 amp circuit to the generator. So step one is I got to get this 1-inch raceway, because I'm going to have 4 number 6s and then that 18.5 going through this raceway. I've done a box offset, and my 90 is going to be at 41 inches. I marked it, and now I just got to throw a 90 in this thing. So I have my raceway ran, comes down 90s, comes all the way, travels behind this box right here, and then I got it to an outdoor bell box. It's 1-inch pipe, and then I got a reducing bushing on the other side, because my whip's going to come out and land right here, and then here are my low voltage terminations, and here is where I terminate to this overcurrent protection device in here, and then I tighten it down through these little access holes right there. Okay, we're inside the dwelling now, and here's the deal. This is my transfer switch. I got all my conductors coming in. I opened this panel up, and it is a rat's nest. So, you know, I could just slap this all in and call it good, but I can't leave my buddy with this. So I'm going to go ahead, de-energize everything. We're going to choose what circuits we want to transfer from this panel to this transfer switch, and then we're going to run some seal tight out. I already opened this hole up right here, and yeah, let's go. Let's get her done. So what I'm doing now is we're determining all the critical circuits we want to run into our transfer panel right there. And I'm going to go ahead, and once I identify them, because this panel was not really labeled, I'm going to mark them with an orange tape. That just tells me this is one of the critical standby circuits that I want to transfer. Okay. All right, so I got kind of a confined area, but I'll making it work. But anyways, I wanted to show you. So I checked the phase balance on this thing, and one phase was pulling way more, about 10 amps more than the other. I think on phase A I had 15 amps, and on phase B I had like 25, so 10 amps out, which doesn't put us in the 10%. But look at that left bus bar, how discolored it is. That's from it being not phase balanced properly, guys. So when you get into these panels and you add circuits, put an amp meter and balance the phases, please. Okay, I got this all cleaned up. Now it's more manageable. And what I've done is all these circuits right here. So this circuit, this circuit, this circuit, this circuit, those are all my circuits that I'm transferring over to this transfer panel. And these are all the circuits that are going to remain on the house power, meaning that when the power goes out, these circuits will not have backup. However, they're not critical circuits. We have chosen the fridge, the bathroom, outdoor lighting, indoor lighting. We got a 220 volt circuit for an AC, and then 2 more circuits, and that should get us there. All right, everything's installed. It's done. I'm going to do a part 3 on the startup of the generator, and you're going to want to watch that. We ran into some issues. It wasn't on our end. Apparently with these Generac generators, you have to register them. If you do not register them, you're not going to be able to get this code that you have to put into the generator, and that prevents you from running it in auto mode. So stay tuned for part 3 so you can figure it out.